Okay, so our next question is factors of a number. Now, factors of a number are the list or set of numbers that evenly divides the given input number. Okay, to explain you more about this, let me delete this title. And let's say we have a number 4. So what will be the factors of it? So we have 1, then we have 2, then we have 4. And I hope you all know about factors and all those things. I'm not going to go deeper dive into that section. Okay, so 4 is evenly divisible by 1. 4 is evenly divisible by 2, 4 is evenly divisible by 4. Now, how to find these factors? That is the question. So let's say we have a number n equal to 4. Let's say we have a list which will initially contain 1 and the given number. Let's keep 8 as the number, okay, to make the list even more bigger. Okay, so we have n equal to 8. So the list will initially contain 1 and 8. That is for sure, because 8 is evenly divisible by 1 and 8 itself. Okay, now what we will do, we will start from 2, then we will keep on checking all the numbers that are there. So 2, 3, 4, 5, 6 and 7. Because we have already included 1 and 8, we will start from 2 to 1 less than the given number. Okay, now what we will do, we will check for each number, that is 3, 4, 5, whether the 8 is divisible by given number or not. Okay, so 8 is divisible by 3. No, it is not. So we'll cancel it out. 8 is divisible by 4. Yes, it is divisible. So what we will do, we will include the 4 into our list. Okay, we will move forward. If 5 is divisible by, if 8 is divisible by 5, no, that is not. 6, no. 7, no. And the execution completes. So we will at the last, we have our list. Okay, so 1, 4 and 8 are the factors of the number 8. See, this is the brute force solution, and what we are doing here, we are actually traversing for all the numbers between, almost all the numbers between the given the 1 and the given number. Okay, so that is not time efficient. So how can we optimize it? So as I told you in some of the previous questions that we solved, that let's say our number is 100. Okay, our number is 100 here. So what will be 100 divided by 2? So 100 divided by 2 will be 50. What do you mean by, let's say, what do you mean by 4 divides 2? So 2 2s are 4 and we will get the remainder 0. In the table of the given number, there exists a particular number which evenly divides. Are you getting the idea? So 50 into 2 is 100, but every number after 15 will exceed the given number. Okay, so let's say we got the value 51, which is the next number of 50. So 51 into 2, we can do this. 2, 5 2s are 10, 102, which is exceeding the given number. So there is no possibility that this number 100 is divisible by the given number 51. Are you getting it? And similarly, for all other numbers that are greater than this 50, okay, so 52, 53, 54, they will not be factors of it. So what we can do, we used to traverse for each number between the two, starting number 2 and the 1 less than the given number. Now what we can do, we can start from 2. Okay, so this is the solution 1. Okay, and we have solution 2 here. Okay, so we will start from 2, then 3, then 4. So in our case 8, so we can divide 8 by 2. So 8 by 2 is 4. So we can go up to the 4. Okay, here I missed one thing. So 2 is also a factor. So we will include 2 here also. Okay, so 2 is a factor, 4 is the factor. So our final list will be 1, 2, 4, 8. Okay, so this will be the final list. Now we can even optimize it furthermore. Now let's say we have a number n equal to 8 here. Now let me write all the numbers that are there between 1 and 8. So 1, 2, 3, 4, 5, 6, 7 and 8. So these are the all numbers between 1 and 8, right? Now we started from 1. We know that 1 is the factor of it. So that means 8 divided by 1 will give some answer. So what is 8 divided by 1? Is 8, right? By finding the first factor, we were able to get the another factor. So 8 is also the factor, right? 8 is also a factor. So we got 8. Similarly, when we go for 2, so 2 is a factor of 8 or not? Yeah, yes, 2 is a factor. Then we did 8 by 2. 8 by 2 is 4. So we got 4 as a factor. Are you getting it? So for every number, we are getting another factor. Okay, so 4 is also calculated. Then we search for 3. Is 3 is a factor? No. Is 5 is a factor? No. Is 6 is a factor? No. Is 7 is a factor? No. We don't need to check these numbers. That will not make any sense. So what we can do, we can optimize it furthermore by starting from 2, and we will go up to the root n, square root of n. Because for every number, we are getting another factor. For every factor, we are getting another factor. Okay. So we can go up to square root of n, and we will eventually find all the numbers. So let's say we have this is the solution 3, right? So list will be 1 and 8 for the first time. Okay, so we will start from 2. So root of 8, that what is root of 8? Okay, so root of 8 is 2. So we got 2 here. So we know that 2 is the factor. So the list will contain 1, 8 and 2. Also it will contain 8 by 2. That is the given number by 2. So 8 by 2 is 4. So 4 will also contain in the list. So basically, when we find any number which is the factor, what we will do, we will store the element itself and the n divided by the given number, that is the 2 here, 2 in this case. We will store both the elements, right? I hope you got the logic. Now let's see how we can write the pseudocode. So I have n equal to 100 here, okay? Let's say this is the user defined input, and it can also be a user input. Okay, now we have a list which will eventually contain 1 and n, the given number. Okay, now I will start from I equal to 2 to I equal to root n. Okay, and I will do that is, let's say if the given number is perfectly divisible by the number that I have right now. Okay, if it is there, then I can, so let's say list dot append. You don't need to worry about all this append and all these techniques. I'm just going to, basically we are adding a new number to the list. Okay, list of number I and n by I. This is not a usual way. What we can do, we can have this and list dot append n by I. I hope you got the logic. Okay, and at the last we can print the list. Hey, there is another use case of the factors of a number problem, that is finding the prime factors of a number. So prime factors are the factors which are prime numbers. Okay, now to explain you more about this, I will delete this title first, and let's say we have a number 25. Okay, so what will be the factors of it? See, as I told you, we will need to check starting from 2 to the n divided by 2. Okay, in the previous question, in the previous timestamp, you should go there and watch that video first. So 25 by 2 is integer 12, that is floor division is 12. Okay, now we will check for 2. Is 2 is the factor of 25? No. 3? No. Then we have 4? No. Then we have 5. 5 is the factor. Then we will check for 6, 7, 8, 9, 10, 11, 12. No, no one are there that are those are factors. Now finding prime factors of a number, what we can do, we can calculate the factors first and then we can calculate prime factors from it. Okay, so 1 is not a prime factor, 25 is not a prime factor, 5 is the prime factor. Okay, so 5 is prime number, so the only value will be 5 here. Okay, this is the solution one, and this is the brute force approach, I would rather say. This is more time consuming. Now there is an optimized approach, and I'm just going to tell you the pseudocode here. Okay, so let's say we have a number n equal to 25. Okay, now as we know that the prime number starts from 2, so 2 is the only even prime numbers that is available, and after that the 3, then we have 5, and it goes on. Okay, now to keep this list in mind, what we can do, we can have initially empty list. So result, let's say result equal to empty for the first time. We will store all the prime factors in our result. Okay, so we will have the result as initial empty list. Okay, now the approach would be that reducing the number, as I told you in the finding the digits of a number problem, that we will need to reduce the number to 0. Okay, and similar approach will be implemented here. So what we will do, we will start from 2. So what we will do, we will initially apply a loop, that is while n, the number n, percent I. So I will be 2 here, because after that we can simply apply a loop, because the incrementation is happening by 2, okay, and here by 1. So what we will do, we will only start from 2 equal to 0. Okay, if this is happening, what we can do, we can simply append to our list. So let's dot append, and we can append 2 here. Okay, now what we can do, we can reduce the number by dividing it by 2. Okay, so n equal to n by 2. So our work will be done here, but what for the other numbers, right? So what we will do, we will apply a loop starting from number 3, because we have already calculated 2. We will start from t, and we will go up to square root of n. And I hope you don't have any problem with square root of n, right? And the incrementation will happen by 2. So I plus equal to, so instead of doing this, what we will do, we will do I plus equal to 2, I equal to I plus 2. Okay, because the numbers are increasing after every 2 numbers. Okay, here what we will do, we will do the same thing as we have done, as we have implemented it here. So while n percent I, so instead of 2 it will be I here equal to 0. So what does it mean, that if the given number 3 is dividing the number or not, evenly dividing the number or not, so what we can do, we can append the result to it. Okay, so we can append the result to it. So result will be appended here, and we can reduce the number by dividing it. Okay, now after that this will complete the process. But what if the rest of the numbers are remaining? So what we will do, we will check for another numbers that are greater than 10. If some numbers are remaining, so while the given number is still greater than 2, okay, if it is still greater than 2, then we can simply append the number. So result dot append the given number. So let's say n is the only number, because there might be a prime factor, there might be a 3 present there. Okay, that could be an option, that could be a possibility. So that's why we are taking care of that possibility, and this is the final answer. Okay, this is the final pseudocode for it. Okay, now let's code this problem, factors of a number. Now we will just going to find all the possible factors of a given number using the technique that we explained in the that we saw in the explanation part. Okay, now I will declare a variable number, because we want to find all the factors of that particular number. So I will take the input from the user. Okay, now the best way of using a list in a C++ is to use the vectors. Okay, so I have declared a vector of int. Okay, and let's say the name is factors. Okay, now to find factors, we will start from 1 and we will go up to square root of a number. So as 1 is already a factor, you can also start from 2, and here you can do something like factors dot pushback 1, and we will push 1 to it, because we know that 1 is already a factor of that number. Okay, so we will start from 2, we will go up to square root of number, and we will do I plus plus. Okay, so this is also the same way, plus plus I, and you can also do I plus plus. Okay, so after that I will check if the number is divisible by the number that I have currently, then it's a factor of that number. Okay, and I'm going to push both the numbers. See, the use of the square root of number is basically for every iteration we will going to get 2 factors. We will going to get 2 pairs of factors. Okay, so one pair, the pair will be, first number is I and second number will be n upon I, n by I. Okay, so here we'll push I, but if in the case that both the pairs are same, let's say for the perfect square, let's say the numbers will be 2 and 2 for the number 4. Okay, so the number, the I and n by I will be same. So here we will check if my I is not equal to number by I. If it is not the case, then I will going to push the number. Okay, if the number is, let's say 2 comma 2, so the number will be 2 is not equal to 2, which will going to fail, and it will not going to push the same number again. Okay, so here we will add the check. Cool. Now after that, I'm just going to print all the numbers in the factors vector that we have. Okay, so let's try to execute this problem. So here I'll create a problem first, and let's give input something like 100. Okay, and if you run it, so factors of 100 are 1, we gain 2, 50, 4, 25, 5, 20 and 10. Okay, so we got all the factors, all the possible factors. Okay, there is another use case, that is finding prime factors of a number. So what I'm going to do, I'm just going to copy this, and let me comment it out first, and here I'm just going to print, and I would write here prime factors of a number. So here I will add a condition for 2. See, we know that 2 is the prime number, is the only even prime number. So we will first check for 2, and let's say if the number is divisible by 2, then we can push the number into the prime factors. I have declared a vector of prime factors, and I can push the numbers into push that number 2 into prime factors, and I will divide the number by 2. See, if the number is divisible, let's say it will going to reduce. So what we are doing here, basically we are reducing the number until it gets 0, so that we will get all the possible factors of it. So here, that's why I have divided the number by 2. Okay, now I will check for 3 and the rest of the prime numbers that we have. So I will check for 3, and I will go up to the square root of number, the usual case that we used to do, and I will just going to move ahead at the odd position, that is I equal to I plus 2. Okay, now I will check if my number is divisible by I or not. If it is divisible, then I'm going to just push back that number, and I will reduce the number. That is, I is basically here for the third 3 number, it will be 3. For 4, it will be 4. 4 will not be there. 5 will be there. So 3, 5, 7, 9 and all those possibilities. Okay, so 9 will be there. After that, see, if the number is if these iterations are over, there could be some numbers remaining. That number can be itself a prime number. So that's why we have checked if the number is greater than 2, we will going to push back the same number. So here I'm just going to printing out the prime factors, and okay, so let me run it. So if you give the same input 100, oh okay, so as you can see here, factors of 1, so this is 1 is basically the number is reduced here. So the current value of number, we will need to store reference of it. So let's say int original original equal to, let's say, number. Okay, and at last we can directly print the numbers. So factors of original number are, let me rerun it. So factors of 100 are 2 to 55. The reason why we got this 2 to 55, if you multiply it, so 2 2s are 4 and 5 5s are 25, and if you multiply it, 25 into 4 will be 100. So these are all the factors. But if you want unique factors from it, let's say 2 and 2 are duplicated, right? So you can either take a set. Okay, you can either take a set, and you can actually push all the numbers in the prime factors after all these iterations. That is your homework. Let's say, see, the step is basically you will define let me include the set here. Yeah, this is how you can include the set. And here what you will do after these iterations, actually take a set or initialize a set and store all elements of the prime factors vector to the set. Feature of set is that it only stores the unique values. So you will get all the factors of it, right? That is unique prime factors of it. So yeah, this is how you can solve the question. Now this is the homework for you. Now it's your time to do the code. Thanks for watching.